Hello everybody, get ready to do lesson 4.4 of Geometry 1 Math, part 1. 4.4, the Pythagorean theorem and the distance formula, part 1. We have a 32-point skill sheet here for classwork and 10 points of notebook work. Here are our standards. Teachers, here's today's bell work. Give your students 3 minutes to do this. Okay, welcome back for our solutions of our bell work. There is number 1. All these angles added together will equal 180. We know 2 of the angles, so the third angle here, measure DEF, would be 70 degrees. 70 degrees here, so DEF would be a 70. Then find the value of the variable here. 2x plus 1 has to equal 81, correct? So x equals 40 here. Okay, in a right triangle, the sides that form the right angle are called legs. So in this situation here, we have a leg here and a leg here. The side opposite the right angle is a hypotenuse. Here's your right angle. Here is your hypotenuse here. Theorem 4.7, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. So here is your famous Pythagorean theorem. And then here it is here, c squared equals a squared plus b squared if the measure of c is 90 degrees. So students, in your own words, define hypotenuse and define legs here. Sample 1, find the length of a hypotenuse. So we have this here. Here's our hypotenuse. We have our legs there. So hypotenuse would equal the sum of the squares of the other legs. We plug in our values. C squared equals 25 plus 144 equals 169. And it'd be the square root of 69, which is what? 13. So C would equal 13 in this case here. Okay, our first guy of practice, find the unknown side length. We have a hypotenuse and we have a leg here. Students, this is yours. You start work on that now, teachers. Let the students work on it now. Wait a little bit here, and then let's go into our solution of this. Page 5. And here would be a x would equal 6 here. You're doing our work with our Pythagorean theorem. Same thing down here. We would get 6.9 for x here, knowing our lengths of a leg and a hypotenuse. We would solve for x. Okay, example 2. A Pythagorean triple is a set of 3 positive integers that satisfy this equation here. For example, form a Pythagorean triple because 5 squared equals 3 squared plus 4 squared. Now, find the length of the hypotenuse of the right triangle here. We have a situation here. We know the length of the legs. So what's the length of our hypotenuse with these legs here? Here's our formula. So c squared equals a squared plus 15 squared. Then we add our 2 legs. We have 289. Well, square root of 289 would be 17. So c would equal 17 in that case there. Integers, they form Pythagorean triple here. And into our next guided practice, we need to find our hypotenuse here. And then here we need to find this. This is our hypotenuse. This is a leg. Students, start work on that. Teachers, give your students a few minutes here. And then we'll go into our answer. Here is the independent practice solution here. It will be 14 for A. And then up here, what would C be? It would be 7.2. So they figure, well, this doesn't form a Pythagorean triple because they're not integers. So they say, oh, it's got to be an integer or else it's not a triple. Well, it's still Pythagorean theorem applies. 7.2, it's not an integer. And that would be the solution. Okay, that was 4.4, part 1. Part 2, part 3 is available here. and everything else you need is here as well. Thank you.